So you've probably been hearing the word transformer literally everywhere in AI lately, right? Whether it's ChatGPT casually writing an email for you, real-time translation systems breaking down language barriers, coding assistants, or even those crazy new image models, so many modern AI systems are built on this exact foundational architecture. But if you're like most people, it can still feel like a bit of a black box. So welcome to this explainer. Today, we are going to break down exactly what happens inside a transformer. We're going to take a really simple, structured journey through the architecture and see how these major components actually work together. Even if you use AI every single day, the first question is usually just, what actually is a transformer? Is it just a fancy buzzword for attention, or is there a whole lot more happening under the hood? Honestly, it's so easy to get lost in the jargon. Okay, let's dive into this and start unraveling the mystery. Our goal today is that by the end of this explainer, you'll be able to look at any standard transformer diagram and actually grasp the architectural logic happening inside it. Let's start with the absolute simplest, most core definition. A transformer is a neural network architecture designed specifically to understand relationships between different parts of a sequence. In language, that sequence is usually a sentence made up of tokens or, words. Take a simple sentence like, the dog chased the ball. For an AI to truly make sense of this, it has to understand the relationships between words like dog, chased, and ball. The transformer pulls this off primarily using a mechanism called attention, which we will absolutely get into in a second, but attention is only one piece of the puzzle. The architecture actually combines a few different components and repeats them to gradually build this incredibly deep understanding of the input. Section 1. The big picture, the high-level pipeline. To make this easy to digest, before we get into the weeds, let's just look at the macro view of the basic transformer pipeline. The whole process always starts with raw text. First, that text gets broken down and converted into tokens. Think of these as the fundamental puzzle pieces of your text. But, well, a computer can't process English words, right? So in step 3, those tokens are converted into embeddings, which are basically just numerical representations. We also inject position information here. This is absolutely crucial so the model knows the exact order each token appeared in the sequence. Next, all that rich numerical data enters the core of the system, the transformer blocks. Inside these blocks, the model repeatedly processes the data, ultimately leading to our final step, the output. Text to tokens to numbers, through the blocks to the output. That is your high-level pipeline. Section 2. Inside a transformer block. Zooming in on the core engine. Now that we have the macro view, let's look at this progressive flow. A simplified transformer block contains 2 major processing stages. You have your input, which flows into the first major stage, multi-head self-attention. After that, we hit a stage called add and normalize before flowing into the second major stage, the feed-forward network, which is then followed by another add and normalize stage, finally giving us our output. Now please, do not panic about the complex math here. For our purposes today, just focus on this flow. We have core processing components surrounded by what are called residual connections and layer normalization, represented by those add and normalize steps. These basically just help stabilize the processing and allow information to flow smoothly through the network. Now, the absolute most fascinating part of this engine is the multi-head self-attention component. This is the magic we mentioned earlier. This is the specific part of the engine that looks at the relationships between all the tokens to determine which ones are actually important to each other. When it reads, the dog chased the ball, attention is the mechanism calculating exactly how strongly the word chased relates to dog versus how it relates to ball. It essentially allows the tokens to interact and focus on the most relevant contextual information. But like we established, attention isn't acting alone. Once attention figures out those relationships, the data passes to the feed-forward network, or FFN. This is the component that takes all that rich attention-gathered data and further transforms the information for each individual token. If attention is the network communicating across the whole sequence, the feed-forward network is the system processing and refining that communication within each token's specific representation. Now, here is a really crucial point about the architectural logic. This block we just looked at, it's not just used once. Instead of trying to force one giant massive operation to understand everything instantly, a transformer uses many of these smaller processing blocks stacked on top of each other. Why? Because it builds understanding step by step. As the information flows from one block to the next, earlier layers might capture relatively simple patterns, like basic grammar. But as the output of one block becomes the input to the next, deeper layers can build much richer, way more complex representations of meaning. And the crazy part? We don't manually assign what each layer learns. The model figures these patterns out all on its own during training. Section 3. Encoders, decoders, and GPT. Different architectures for different tasks. Having seen those micro-level blocks, let's zoom back out and see how they're arranged. The original transformer architecture actually had 2 major parts, an encoder and a decoder. The encoder processes the input to build a representation, and the decoder uses that representation to generate an output. Think of translating a sentence like, I love AI, into Spanish. The encoder processes the English sentence, and the decoder generates the translation, step by step. But modern AI models don't all use this classic structure. In the GPT style, models like ChatGPT use a decoder-only architecture. Instead of translating a complete sentence, it takes an input, runs it through stacked transformer blocks, and is trained to literally just predict the next token. If the input is the sky is, it predicts blue. Then blue becomes part of the sequence, and it just keeps predicting the next word. Section 4. Putting it all together. The journey of a token. Let's rapidly recap this progressive journey we've just uncovered. We start with text, which becomes tokens. Those tokens are turned into numerical embeddings along with their positional information. That data enters a stack of transformer blocks. Inside every single block, attention helps the model figure out which tokens matter to each other, and the feed-forward network further transforms that information, all stabilized by residual connections and layer normalization. Block after block, the representation gets richer and deeper, resulting in a highly complex final representation. And finally, in a generative model like GPT, that final representation is used to successfully predict the next token. Section 5. The impact of transformers, the building blocks of modern AI. So, why do these specific building blocks matter so much? Well, because this architecture quite literally took over the world. It is incredibly effective at learning relationships across sequences, and vitally, it can be trained efficiently at a massive scale by stacking into very deep networks. This basic architectural logic has been adapted for an astounding variety of tasks. We're talking powerful language models, seamless translation, instantaneous code generation, complex document understanding, advanced image processing, and cutting-edge multimodal AI. The transformer isn't just a buzzword. It truly is the foundational building block of the modern artificial intelligence revolution. We've taken a solid, beginner-friendly look at the core mechanism and the architectural flow from start to finish today. But, there's always more to uncover. Now that you understand how text becomes numbers, how attention finds relationships, and how stacked blocks build understanding, I have to ask you, which piece of the transformer are you going to explore next? Will you dive into the distinct roles of encoders and decoders, or will you zoom into the fascinating, detailed mathematics behind attention? The foundational map is now yours. Keep exploring.